What's happening, dogs? Mr. Allen here. We're about to write this rational expression as a single fraction, and we're going to list any domain restrictions. All right, in order to get these domain restrictions, this bad boy needs to be factored because I can't tell what's going to make my denominator equal 0 here or here. So let's start by factoring, and that's also going to help us find our common denominator because right now, these bad boys ain't the same. All righty, so I'm going to have x plus 3 and x plus 1 for this one is 3 times 1 is going to give me 3, and 3 plus 1 is going to give me 4. And then over here, I've got x minus 5 and x plus 1. Negative 5 times 1 gives me negative 5. Negative 5 plus 1 gives me negative 4. Boom. Diggity. All right, so off to the side, I'm just going to jot this down. X cannot equal, it would be negative 3. We're going to have negative 1. And I got positive 5 and also negative 1. I don't need to list that one twice, right? So those are my domain restrictions. That's going to be a part of my final answer that I got right there, okay? Beautiful. That's wonderful. Now, I got to figure out, well, what does each part need? And when we have these trinomials that need to be factored, it can actually be kind of easy to see everything, right? Well, they both have this, yeah? But this guy don't have that, and this guy don't have that. So I need to go ahead and multiply by x minus 5 over x minus 5 on this one, okay, right? X minus 5 divided by x minus 5, that's just 1. So is this changing this fraction at all? No. It's going to look different, but it's mathematically equivalent. And this guy needs to be multiplied by x minus 3 over plus 3, x plus 3. Beautiful. So now they're going to have each other's factors, right? So this first one here is going to be x times x minus 5. And then we're going to have minus 3 times x plus 3. And all of that can now be in one fraction over my least common denominator, which is x minus 5, x plus 3, and x plus 1. Woo! Dang, son. That's crazy, right? So this one here, x plus 3, x plus 1, x minus 5. Beautiful. Here we got x minus 5, x plus 3, x plus 1, they are the same. It can be written as one fraction. Now I got to do a little bit of math in my numerator, okay? And I'm actually going to change colors right now to do a little numerator math, and then we'll put it all back into the same color once I'm done doing some simplifications there. So I'm going to have x times x and x times negative 5. So it's going to be x squared minus 5x. And then we got negative 3 distributed. It gives me negative 3x minus 9. So here I'm going to have x squared minus 8x minus 9. Can I do any factoring with that? I've already combined my like terms. I most certainly can factor. And now I'm going to switch back to this pink one because we're going to put all in one fraction. So here I've got, let's see here, x minus 9 and then x plus 1, right? That multiplies to negative 9 and adds to negative 8. The whole big fraction, we got x minus 5, x plus 3, and x plus 1. Can I simplify? Because now I'm allowed to simplify, right? I can't do that up here because there's subtraction between them. I can't cancel the x minus 5s and the x plus 3s. As tempting as that is, it's a no-go. It's a no-go, dogs. All right? Right now, everything has multiplication between them, right? Because when I have addition or subtraction, the whole thing's got to go. So can I cancel these x plus 1s? Heck yeah, they can leave the rational party right here. And now I have x minus 9 over x minus 5 times x plus 3. Beautiful. Where x cannot equal negative 3, negative 1, and positive 5. Even though we canceled out the part that would make our denominator 0 with the negative 1 there, even though we canceled that out, that removable discontinuity, it's still part of my domain restriction because it would make my original problem undefined, right? It would have made actually both fractions, both of those guys would have been 0 because negative 1 getting plugged in. So there we have it. That's our simplified form, and then there are the domain restrictions. Thanks, son. That's dope. That's awesome. See you later.